So we have this bounded region, and we want to revolve this bounded region about the around the y-axis and find the volume of the solid of revolution. So we have this function, the square root of x plus 2, which is this line, which is this graph right here. And then the graph g of x equal to 0.5x, which is this graph right here. X equal to 1 is this vertical line, and then x equal to 5 is this vertical line. And the axis of revolution is the y-axis, or the line x equal to 0. And so we have this bounded region, and we'll revolve it around this axis of revolution, and we'll use the shell method. And so first we'll fill the bounded region with rectangles, vertical rectangles, since the axis of revolution is vertical, and we'll fill it with the vertical rectangles. And then we'll take each rectangle and revolve it about the around the x-axis, the y-axis, and we get shells, and we'll find the volume of the shells and add them together, and that will give us the volume of the solid of revolution. So the shells would look like this. This is the shell corresponding to the this rectangle number 5. This is the shell corresponding to rectangle number 4, number 3, number 2, and number 1. And of course, if we fill this solid of revolution, if we just fill it up with just 5 shells, then we'll just get an approximated volume. And to get the exact volume, we have to fill the solid of revolution up with an infinite number of shells, and then we find the volume. And so for any shell, for the ith shell, the average radius, let's talk about the average radius first. The average radius is the distance from the x-axis of revolution to the center of the shell. So the average radius would be the distance from here to here. This is the center of the shell. So it'll be some x distance. And so the average radius is just x. The height of the cylinder would be the top graph minus the bottom graph. This graph is the square root of x plus 2. This graph is 0.5x. So once more, this is the graph y equal to the square root of x plus 2. This is the graph y equal to the square root of x. And so the height of the shell would be the top graph minus the bottom graph. So in this case, it'd be square root of x plus 2 minus 0.5x. So this is the height of the cylinder. The average radius is x. Note that x ranges from 1 to 5. So 1, the shaded region, ranges for the x ranges from 1 to 5. And so setting up the integral to get the exact volume, if the limits of integration right here would be 1 to 5. So the average radius is x, the height is f of x minus g of x. The thickness of the shell is dx. So we have 2 pi, and then integral of x. F of x is the square root of x plus 2. G of x is 0.5x. the square root of x is the same as x to the 1/2, and then multiply this out. X times x to the 1/2 is x to the 3/2. X times 2 is 2x. X times 0.5 is 0.5x is 0.5x squared. Antiderivative for x to the 1/2, add 1 to the exponent. 1/2 plus 1 is 3/2. Antiderivative, let's do that again. Antiderivative for 3/2 is add 1 to the exponent. 3/2 plus 1 is 5/2, and divided by 5/2. Antiderivative for x is x squared divided by 2. Antiderivative for x squared is x to the 3rd divided by 3. Dividing by 5/2 is the same as multiplying by 2/5. 2 divided by 2 is 1. 0.5 divided by 3 is 1/6. And then we evaluate from 1 to 5. So first plugged in 5, 5, and 5. And the lower limit of integration is 1, so we're plugged in 1, 1, and then 1. And then simplify, and then all of this will be 158.926971, and so on. So the volume of the solid of revolution is 158.926971.